Welcome to our live training session number 39, part 6. In this video, we're going to learn how to set up our cold start and warm-up enrichment on day 2 here of our live training session, as well as learning how to set up a basic launch control using our AEM software. We're going to have a lot to cover, so let's jump into our live training session so we can get started. Welcome back to our live training session here with our turbocharged Honda S2000. In the last video, we successfully mapped out our boost control. After we set everything up in the closed loop format, we went into the target table and went into the speed-based boost and set up a basic speed-based boost table so that it has a target boost to follow, and it ramps boost and power in as the vehicle is accelerating so it can put power down more efficiently. So that was a relatively straightforward process. At this point, we went through pretty much all the things and all the details to properly tune this vehicle. Now we're ready to take a look at doing the cold start and warm-up enrichment on our day 2. Now, a couple things about this that's really important to keep in mind. When we were working in our main fuel table here, jumping into the fuel table, this represents the low cam of operation. More importantly, this represents the engine's fueling when it's warmed up. So after the engines went up to about 170, 180 degrees coolant temperature, this table is going to provide the fuel, and we're going to find that it's going to be pretty accurate. Now, when we fire off the engine cold, it's going to have what's known as a wall wetting effect, where the fuel is going to stick to the intake track and the intake valve. It's not going to make its way into the engine as efficiently as a warmed up engine. That's because the heat allows the fuel to atomize properly. So we're going to get in a situation here where we need to add fuel above and beyond what we have from our normal post-start tables and our normal cranking tables for a warmed up engine. We're actually going to have to add more fuel to be able to overcome this wall wetting effect, to get the same kind of air fuel, get the same kind of burn from the engine, because again, that fuel is not going to make its way all into the engine up to a point where it gets up to normal operating temperature. So we're going to have 3 different tables to deal with. We're going to have our cranking tables here. Actually 4 different tables technically. We have our initial crank pulse table. This is going to be providing a prime shot, similar to the idea of a prime on a carburetor. This is going to be priming the combustion chamber with fuel, so it's going to be squirting a huge amount of fuel to get the engine to fire off when it's cold. We can see here it's based on coolant temperature versus actual milliseconds or raw pulse width to inject. So this is going to be looking at our coolant temp right now. We are at 54 degrees. We're right here in the table. We can see our little cursor. The value that we're going to be trying to inject into the engine here is 18.8 milliseconds. This is going to be, again, we'll take a look at this in the data log. This is going to be a huge shot of fuel for the first 1 or 2 cranking revolutions of the engine. As soon as it starts to get above that 1 or 2 revolutions of cranking, it's going to move now into the injector crank time table here. This is going to be providing more of that long-term injector pulse width as it's cranking. So if we're having problems starting, we're not going to adjust our crank time table here. This is going to be just kind of a fixed crank pulse as we're going and injecting fuel hot or cold. We're going to be taking up the difference if we have a problem starting using this table here. So it's going to be important that we evaluate this performance with this table. And if, again, we have a problem, if it takes a lot of cranks to fire, this is the table we're going to go after by increasing the fuel. Now, once it fires off and it reaches about 450 to 500 RPM, it's going to be exiting inside right here. We can see crank max RPM. Once it exits 400 RPM, it's going to consider that to be an engine that's running. It's going to go then transition into our start extra versus temp table. This is our post-start. And then it's going to be transitioning then into the warm-up enrichment. So it's going to be transitioning kind of through these tables. We're going to look at that in a data log and see how it's going to go. Now, in my channels here, we have some parameters. We have stat synced. This parameter has to turn on while we're cranking. If it doesn't turn on, then we're going to find that we probably have an issue with the battery voltage, or there's a problem with the actual cam or crank sensors. Now, on a cold engine like this, it's going to tax the battery more. So we'll find if the battery's weak, it may not crank to fire, and we might find here that the stat sync never turns on. If it doesn't turn on, we're not actually going to be firing the coils or injectors from the AEM. So it's important that we... Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.